Okay, so for our next problem, we have to use a zero to find all the zeros and write a linear factorization. So this one's a whopping one, big one. Here we have our function. We're given this zero here. So the first thing I need to do to break this down, this function down to find the other zeros, and to break down to find the factors, is to synthetically divide. So I synthetically divided, and that gave me a whole new list of numbers here in red, which I can synthetically divide with again. Remember that if you have a complex zero, then its conjugate is also a zero. So I synthetically divided one more time with these red numbers, and I ended up here with a quotient, the 4, 8, and the 13. I synthetically divided twice with this function, starting with the power of 4, so we whittled it down to a power of 2. And I want to find the remaining zeros, so I just set that quadratic equal to 0, and I completed the square to find the remaining zeros. Now you guys remember, once we have the zeros, we have the factors. So I have the zeros here, so now I have the factors. And what am I missing? What's wrong about this? Well, this factorization is incomplete without a leading coefficient of 4. That 4 needs to be at the front here. I forgot to write it. So let's move to the next one. What do we have next? Okay, so this next one, we're solving the inequality with a method of your choice. We can solve inequalities, rational inequalities, by finding the zeros. The zero of the numerator is a 1, and finding where we have division by 0, and finding the signs in between and after each one. So what I did is I literally plugged in values prior to -2. I plugged in a value like -3, and I found I was in the negative. I plug in a value in between -2 and 1. I found that I was in the positive. And then I found I'm in the negative, and then in the positive. And so that told me what values will satisfy the inequality. Now, I'm looking for what x values will give this a positive, so I see if I plug in anything in between -2 and 1, I'll get a positive, and anything after 2, I'll get a positive. Now that might be a little bit shady for you, so you might want to focus on graphing the rational function on the left. If you graph the rational function on the left, you'll have two vertical asymptotes, and then you have a x-intercept. And if you graph and plug in values, you'll know where to place your graph. By plugging in x values, you know what the y values are doing, and so that visual might help you understand where you're actually in the positive. What x values will result in y values that are positive. So clearly we can see up top here we're in the positive. That's from -2 to 1, and from 2 to infinity. So let me see the next one here. Okay, so this next one involves graphing logarithmic and exponential functions. So logarithmic functions, remember, are inverses of exponential functions. So it really helps to understand what a basic logarithmic function looks like. It looks like this one here. To graph this log function, I would recommend rewriting this function, this base graph, into a exponential function, just rewriting 2 to the y power is equal to x, and then creating a list of table of values to create that first base graph here. Once you have the base graph, then you have to understand what's going on here in order to create your transformations. Like right here, when I add 3, that tells me that is a horizontal shift left, but then I have a reflection over the y-axis. So over here, that's what I've done over here, is I've shifted to the left and then reflected over the y-axis. This next one here was 16. I plugged in x to get y, and that gave me my base graph there. And then I know that these will reflect over the x and the y axes. So that's why I have negatives in front of my original x and y values, and then I plotted the points. Okay. So our next one here, we want to determine an exponential formula. And remember, in exponential formula, we have a times b to the x power. We have to find out what the initial value is and what is the value at which we're increasing by or decreasing by each time. So the initial value is easy. That's when x is 0, the y value gives you that initial. The initial is 3 over 2 because the x value is 0 here. Then we need to figure out what the b value is. The b value would be pretty easy if the x value was going up by 1, but it's not. So, for instance, if the x value is going up by 1, I could just look at the y values to see what the increase or decrease is, and that would represent my b value. But now I'm jumping here, and I have to plug in this x is 2 and y is 3 over 8 times e to the second to identify b. That's what I have in this step here. And then from here to the next step, I multiplied by the reciprocal to get this, and then I took the square root of both sides to get the b value, and that essentially gives me my exponential function. And remember, we can plug in x to get y to make sure that actually matches up with our table of values. Okay, our next one here, we have to write a sum or difference of logarithms or multiple of logarithms. So the first thing, let's see, the first thing I did here is I used the quotient rule, and from the quotient rule then I noticed that I had the power rule on the product rule on the right, 36 times y to the third power. I broke that apart, remembering to keep the negative in front of the entire quantity. And then the last thing I did is I used the power rule, and then I evaluated this log base 6 of 36. 6 to the second power is 36. Alright, this last one here, actually not the last one, I'm sorry, this next one, we want to write the expression as a single log. So we have to work backwards, and we are I find it most helpful to just look at the logs on the left and move our way to the right. So the first thing I did is I just looked at these two logs on the left, and first thing I did actually is I rewrote using the power rule, and then I looked at the logs on the left and used the quotient rule, and then the product rule. A lot of people would incorrectly have put the y squared in the denominator, which is incorrect. Take it step by step, piece by piece, working from left to right, and you'll be all good. Alright, so our next one here, I noticed some people were approaching this one with the quotient rule, which is okay, but we want to evaluate, we want to figure out what this entire log quantity is equal to, and so I just set up what is it equal to. And then I rewrote using the exponential form of this log function. It makes more sense to me. And then I said, okay, well, I'm going to start manipulating the right-hand side so that I can somehow possibly have a base of 6. Because if I can identify a base of 6, I can figure out the exponent that question mark represents. So root 5 means fifth power, and then 36 can be written with a 6 to the power 2, and then we're going somewhere over here. We have the power to a power, I multiply exponents, and then my 6 over here is in the numerator, so I want this base 6 in the numerator. So I cross the line, change the sign of the exponent, and that tells me what that logarithmic expression is equal to. It's negative 2 over 5. Alrighty. 21 here. Okay, we have to solve for x. And I want to somehow get to that exponent. And so the first thing I did is I just got rid of the 80. I divided by 80 on both sides. 240 divided by 80 is 3, and then this is making a little bit more sense, a little easier to comprehend. To get to that x, we would need to use the power rule, and so I have to take the log of both sides. You can take any log. I had decided to use log base e because I have an e here, and I know the ln of e is e. Remember that log base e of e is 1 because e to the power of 1 is e. So from here, I used my power rule with this entire quantity as an exponent, pulled it in front of the log base e, and then the log base e goes away because it's equal to 1. And then I solve for x, just a matter of solving for x. One thing we could do is evaluate what this expression is equal to and plug it back into our original to see if we're correct or not. I'll leave that to you. I can help you out with that later if you need my help. Alright, so this one here we have to figure out what x is equal to with this logarithmic equation. And so the first thing that I'm looking to do is to isolate the log. So I subtract 3 and then divide by a negative to give this logarithmic equation. Once log is isolated, we can evaluate into an exponential equation. And when there's no base written, it's a base of 10. And 10 to the negative 2 is equal to this quantity here, x plus 2. And then it's a matter of just solving for x using our algebra skills. Alright, this next one, solving for x. What the goal is right at this moment is to use these two logs that are separated with addition to create a single log, condense into a single log, so that we can evaluate using the one-to-one rule for logs. So I used the product rule, and then from there I had a log on both sides, and I have this circled in red and this circled in red to show you that in order for this to be a true statement, what's in red, what's circled in red, has to be equal to each other. So that enabled me to just get rid of the logs to evaluate this equation. And then I have this quadratic. I pulled the 9 on the other side, and then I tried to figure out, or I figured out what it was using the quadratic equation this time around. And let's see here. I knew that I could only have the positive version. We got a plus or a minus root 85, so I got rid of the minus because the minus results in a negative value, approximately equal to a negative 6. And if I plug in that negative 6, minus 6, that will result in, if I go to the numerator, what am I saying? If I go to my original equation and plug in that negative, approximately negative 6 here, I have a log of a negative number, and there's no way I can raise a base 10, a positive, to some number to change the value of the base to a negative number. So anyway, guys, I think that's it. If you need me to clarify more, I get it. I will gladly do that. I'm sort of at the end of my rope right now, and Elizabeth is here waiting for me. And I'll gladly answer any more questions if you have them. Okay. All right. Good luck studying.